Hello, this is demonstration of WhaleSwap. To do a demo of AMMs, you require liquidity on the testnets. Arranging liquidity for testnets demonstration wasn't feasible, and hence I am showing the demo through writing tests. I have here simulated multiple tests because simulating tokens and all of the contract deployments is much easier on the tests because you can immediately assume that all the you have infinite number of tokens and you can allocate any number of tokens to any pair, any contract as you wish. Here I am showing swap of two tokens. For that, first of all, two tokens are created and their named are just randomly named token A and B. A factory contract and the whale token contract, which will act as liquidity token for the liquidity providers to track how much liquidity each liquidity provider provides, so that whenever we share the fees collected through traders on the AMMs, it can be shared with liquidity providers depending upon how much liquidity token they have. The share of liquidity token represents their share in the reserve of liquidity. Next, we instantiate a pair of those two tokens using the factory contract and supply 10 ether worth of both token to the contract using which we are going to demonstrate all of the tests. First of all, we are testing here the mint functionality. Mint functionality, as I explained earlier, basically mints tokens for the liquidity providers to track how much how much percentage of the liquidity is shared by them in the current pool. It helps in managing how much percentage of the fee they will get as the reward. So to test this function, first of all, we have transferred one ether worth of both tokens to the pair. So this creates a pool of total of 2 ether, and both token have liquidity in equal amounts. This shows these both have equal worth on the token, like you can say USDC or USDT. Then we have tested here that after minting tokens for the liquidity provider, which is the current contract in this case, after minting tokens we have checked whether the current contract which has been liquidity provider for the pair has 1 ether minus 1000 of the balance. Why the minus 1000? We can check this through the actual contract and the actual function. So here, as we can see, when the total supply is 0, a fixed amount of minimum liquidity is removed from the liquidity provider, because we want to maintain a minimum liquidity in case if the first liquidity provider removes 100% of its liquidity, there is still some of the liquidity remaining in the pair. Minimum liquidity is defined as 1000, as you can see here. After that, since one ether worth of both tokens are provided, we can check the reserves have 1 ether worth of both tokens. Asset reserve function is defined by us, which basically makes sure the right order and right tokens are matched with the reserves. and here we are seeing that the total supply of the liquidity tokens, there is whale token here, is 1 ether because we have supplied 1 ether worth of tokens for the pair. Next comes here the burn functionality. Burn functions are mainly used whenever we want to remove, if a liquidity provider wants to remove the liquidity out of the pair, then they have to burn the whale tokens, and on burning whale tokens all of the liquidity provided by them will be transferred to them, whatever the amount they want to get back. So here we have done that, just again simulating same things. First of all, providing 1 ether worth of tokens of both tokens to the pair. So what we did here is not applicable for this function. This is, we have to do this again and again. So this is again starting a fresh pair. In the fresh pair we have 1 ether worth of both tokens, and then we minted liquidity tokens for the, that is whale token for the liquidity provider. After that we transferred all of the liquidity provided tokens to the pair contract. It is currently done manually, but in actual scenario it would be done by the router contract, because then only the pair contract will be able to burn the liquidity, or actually delete the liquidity out of the, because till the point we are holding whale tokens, pair contract cannot control the whale tokens, cannot burn them. So we have to first transfer all of the whale tokens to the pair contract, and then call burn function in the pair contract to just burn all of that tokens. And this will basically remove all of the whale tokens burned by us from the total supply. Then we can check the balance is 0, and since we are the actual liquidity provider, the first ever liquidity provider, minimum liquidity will still be inside the pair, which we already discussed earlier, of 1000 GUI. And then we have total supply will also be 1000, and the total balance of, because we have 10 ether worth of balance, as we can see here, we have 10 ether worth of balance, and since we have claimed all of the liquidity, but 1000 V's are still in the pair, so we will, so our current balance, the new balance will be 10 ether minus 1000. We can also, let's just run this. So as you can see, this all passes the test. For a quick recap, we have a factory contract which basically allows us to create a new contract for every unique pair of tokens. For example, we have, let's say we want to swap between XY and USDC, and there isn't any pair already existing, a contract already existing for providing that swap, then that pair or that contract can be generated through the factory contract. So it will generate a new pair contract. This pair contract basically holds two tokens, XY and USDC, for example, and another token which will be the WhaleSwap token, or literally, or simply the whale token, which will be the liquidity token for tracking how much liquidity is provided and in what share. So in total there are three tokens. Two of them are part of the pair contract and another one is for just tracking the contribution of the liquidity provider in creating that pool. This token will contain all of the XY and USDC provided by liquidity providers, so that if someone provides USDC, they can get some of the XY in exchange, or if someone provides XY, they can get USDC in exchange. Similarly, there can be multiple pairs. For example, there can be a pair for ETH and USDC. So this contract will keep record of how much ETH, how much USDC, and how much whale tokens are holded by which, are provided by which of the addresses. So how do AMMs know the prices of the USDC or ETH at a point? It's simply dependent on the ratio of how much liquidity they, ratio of the reserves of the tokens. For example, if I want to start this contract at this point of the time, and currently I know ETH is somewhere around 2.5k USDC. So if I want to provide, I want to create this new pair on the WhaleSwap, I will be providing ETH and USDC in the same ratio. For example, if I am providing 10 ETH to the pair 2 contract, then I will be providing 25k USDC, so that this ratio remains same. If I don't obey this ratio of the market, and let's say provide 10 ETH and 5k USDC only, then anyone can buy 5 ETH for just 2.5k USDC on the WhaleSwap. This will not harm WhaleSwap, it will actually harm the liquidity provider, because they lost their 5 ETH at just expense of 2.5k USDC. While this was just the core part of the WhaleSwap or AMM, but there is a whole uh, abstract level of contract which allows direct access to these functions. A user don't have to remember, like they have to transfer tokens and then they have to mint whale tokens. All of this process is abstracted into single functions, so they can simply press one or two buttons and call add liquidity, remove liquidity, swap between one token to another token, even uh, to support CrossFi with its native token XFi. We have, because native tokens, EVM compatible chains have these native tokens, and these native tokens don't have the ERC20 specific capabilities to make it exactly behave as ERC20 tokens, because AMMs only support ERC20 tokens. We have make use of wrapped XFi, which have equal value of the XFi. So for each one XFi you deposit to the WXFi token, you get one XFi token. If you deposit two XFi, you get two WXFi. And this basically is the exact store of value as the XFi for that moment, and allows us to uh, all use all the goodness of ERC20 tokens, and without any extra effort by the user don't have to ever care about that there exists any other token. They can just simply come with their xfi tokens and do the swaps between their xfi and usdc or usdt or whatever pair they want to do. So that's most of it, and enough for the I guess requirements of the demo purposes. So this was Amit Kumar Mishra. Thank you.